Okay, well, good afternoon, everybody. Guten Abend. It's very warm today, so I'll try and keep it as succinct as I can. The idea of this presentation is to go through meeting the needs of the industry when it comes to powder handling. Everyone's talking about 3D printing, 3D, linked 3D earlier, talking about value chain and how to try and incorporate data management. But some of the fundamental base principles of powder handling is very key for customers who are looking to do efficient 3D printing processes, but also to upscale into the future. So it may not be as complex as 3D printing, but it is a very important part where you've got to consider some key things to make sure your process works well. For us at Finex, we're an 85-year-old company. We've been around for, well, like I said, 85 years, and we are focused specifically on sieving and filtration equipment. We've got companies around the world, so wherever you are, we can support your needs. So in terms of what we do, there's a big process from where the 3D printer is all the way through to when you've got that powder. So most of the technologies which are being productionized do have a powder. That powder then needs to be managed. So you've then got to recover that powder, requalify that powder, and then put it back into the process. Powder can be very expensive, there's lots of labor involved, it's very labor-intensive operation, handling the powder, there's safety considerations, so all of these things have to be considered in your 3D printing production environment. We focus on this area, so you've got the printer through to vacuuming the powder out of the printer, but then you've got the sieving station where you want to qualify the powder, you want to blend new powder back in, and then that powder needs to go back into the process. So this is where we specialize. And as I said, we've been in the industry for about 85 years, so we hope we can bring something to the table. What we see is two main areas where you're handling powder. The first area is when your powder is coming into your factory. And you're hoping that your supplier is looking after is sieving your powder and qualifying that powder before they deliver it to you. But it's very important that you have like an audit control on the powder. So when it comes into your factory, you want to make sure it's sieved and clean before it goes into your printers or into your process. We see this a lot in lots of industries, whether it's food or pharmaceutical. They're all wanting to make sure you've got a proper audit stop point where the powder is then deemed as fully clean, and then it can go into the process. So once the powder's in the process, the next stage is to actually recover that powder and make sure that powder is then cleaned and requalified, ready for reuse. We see this as a big value in metal powders, but certainly the plastics, where people are using more and more plastics, where you're getting more complex plastic powders. They don't want to just throw them away, so it's important that you can recover the powder. So these are the two main areas where we focus on providing a solution. But when we look at the solution that we provide customers, you've got to look at various different ways your factory is operating. So we take our customers down a route where you ask specific questions about how your process how your process is set up. So some of the questions like, how much powder do you have? If you've got a small batch of powder, then it's going to be quite a different setup to if you've got tons of powder. If you're in the aerospace industry versus prototyping industry, then there's going to be different considerations when it comes to validation control, traceability, and lot tracking and things like that. If you've got multiple printers or multiple technologies, how are you looking at integrating those technologies into one powder handling system? So all of these questions we need to ask our customers, and there isn't just one solution. So it's very important that you go out there, you talk to your OEMs, you talk to your suppliers, and you really ask these types of questions to make sure you've got a solution that suits what you've got now, and then what's coming in the future. So these are the four key challenges that we're looking to try and achieve or have solutions for in the industry. So we have reducing manual handling. This is one of the key pain points in the industry, which is the most obvious pain point. Your operators are having to do lots of manual handling. They're lifting heavy containers, lots of auxiliary equipment that they've got to store or move around. There's risks of equipment falling over, so safety of operators is very key. So reducing the manual handling tasks in powder handling is very key. You want your operators to be using the printers, getting the parts out of the printers rather than playing around with the powder. The powder process needs to be as automated as it can be, so you're getting as maximum productivity out of your process. Containment, as I said, operator safety is really important. So making sure that the operators aren't exposed to powder is a very big growing concern. The more powder you have, the more productionized you have, the skill of the operators may be reducing as you're becoming more of a production facility rather than an R&D facility. So making sure you've got a very robust, safe system is very important. Controllable and repeatable. So if you talk about aerospace and medical or dental, these types of industries demand, a very, very strict validation process. And you need your powder handling process to back that up. And as I said, safeguarding, not only when you're looking at safeguarding the operators, you want to safeguard the powder. So the powder is what's making your parts, it's what's going into planes, it's going into teeth or medical implants. The powder is the most important part of the process. So you need to make sure you look after that powder. So it's looking at things like environment control, humidity, oxygen levels, things like that. And obviously the contamination that goes in there from airborne contamination or from in the process itself. So these are the 4 main challenges of the industry. Now, one thing I wanted to touch on is, if you look at the 2 main ways of doing it at the moment, is you've got bottle handling. So if you want to be able to you've got your powder in a container, sealed, you can write on it, you can barcode it, that powder is locked as a batch. The only downside to that process is that you've got to get that powder out of that container and into your printer. So to do that, there's lots of different pieces of equipment that you need to move that container around. You may have lots of containers, lots of different powders, so all of a sudden, one bottle turns out to be a lot of equipment and takes up a lot of real estate. So you can't just put all your printers in the factory. You've then got to consider trolleys, lifters, bottles, etc. So there's lots of space that's taken up by the bottle handling process. But it is a very neat way of controlling the batches. So, and the other side of bottle handling is it's very labor intensive. So your operators are having to spend a lot of time moving containers around. There's more likely issues with spillages of powder. So if your operator is moving containers and opening valves and connecting things, there's more likely to be a spillage. And we don't want that. When we go back to my original slide, safety of operators is the number 1. So to make sure that you've got that locked down and secure is very important. So there's 2 key ways. You can look at bottle handling. Another way of doing it is trying to convey the powder and move the powder in a locked closed-loop system. And that's what we're trying to move towards. We've got systems that we that we have in the market, and there's many OEMs who are trying to do the same thing. It does come with its challenges. How do you make sure the system is clean? If you need to change powders or you get a contamination situation, how do you remove that contamination? So the more complex the powder handling process, it may become more automated, but it can become more complex. So you've got to be quite careful and get a balance between the 2. So this is our main product range. We do lots of different machines, but you have, and it comes down to where you are in your walk or your evolution of your company. Are you a small prototyper? Are you looking to grow to be a bigger manufacturer, or do you support OEMs as a service center? It really depends. Where you sit in the industry will depend on what type of sieving station or powder handling system you will use. So there's just a few, but it comes down to you going through that list of questions with your suppliers and saying, this is what I'm going to be looking at doing now and into the future. And if you ask those questions, hopefully your supplier will be able to come back with a more robust, future-proof solution. So we went out to the industry about 20, 30 years ago, recognizing that the industry is growing, it's becoming more industrialized. How can we support the industry as a specialist in sieving powder handling to make sure that the industry can grow in the rate that it's currently growing, and future-proof and safeguard the industry as it develops. So, a lot of the key things that we have up here they're prerequisites for the industry. So we come from food and pharmaceutical background, so a lot of these requirements are already known to us from different industries. So what we've done is look into what we've learned from other industries and try to put that into the AM industry. So things like ease of cleaning. So we use a pharmaceutical spec equipment, so crevice-free, minimal contact parts, easy quick change items, so that if you do need to change materials or remove a contamination issue, then using the solution we've put up here will mean that you can really you can speed up the turnaround, so you're not having massive production downtime. Another key requirement was automation. So, as I said before, if you're doing bottle handling, you've got an operator who is tied up to that operation pretty much 24/7, depending on your operation. So being able to go to a recovery system, push run, and ensure that that system will run without any problems was our #1 priority. So that's why we put a lot of our effort into understanding what are the key issues with the powder. It bridges, it blinds. The sheer nature of the powder is very, very difficult and challenging for a sieving specialist to deal with. And I'll talk more about that later. Having a small system, you've got facilities where they're temperature controlled, humidity controlled, they're expensive to run, so you don't want big auxiliary equipment taking up lots of floor space. So you want to keep your systems as small as they can, but you want to make sure you've got that fast efficiency to get your powder back through the process again. You don't want lots of powder in your buffer. You want to have the amount of powder that you need for your particular process. And then the final one really is our challenge, not yours. It's how we can make sure that the sieve mesh is kept in best quality as we can. So the mesh on the machine is doing all the work. If your mesh is compromised, then it doesn't matter what your system is, you're going to have problems. So the sieve mesh is the most important part of the process. So this sort of just illustrates the type of issues that you're going to have. So with the powder that is from metal powder in particular, from the atomization process, the actual powder is highly spherical. So it's basically a sphere. And the particle size distribution is very close to the mesh aperture size. So the hole in the mesh, which you're sieving through, is a very similar hole size to some of the powder particles, which makes it very, very difficult to sieve it. These particles want to try and sit in the holes in the mesh, and if you're not controlling the sieving process, then you're highly likely to have mesh failure or reduced throughput rates, contamination issues, etc. So it's really important that you prevent this phenomenon from happening. With our sieving systems, we are proud to say that we've overcome all these challenges. We can have maximum flow rates. We have flow rates typically about 400 kilos an hour when it comes to titanium, 200 for aluminium. So if you're looking at fast sieving times, you want to get your powder back into the process as quick as possible, then we've got a system that can allow for that. Your mesh life is increased, so your operators aren't having to do maintenance regularly on the machine. They can be confident the machine is working well, and reduce product wastage. So normally in a sieving process, you will have the contamination removed from the sieve. If that process isn't efficient, then you're going to lose good powder with the bad powder, which means you're either having to rescreen the powder or you're going to lose the powder. So this is what bad mesh looks like. So this is what you don't want in your sieve. And this is actually to an ISO standard. So you can see there, that's actually 63 micron mesh. And you can see the apertures are very varied. And you've got weaknesses in the wire. So this is really important that you don't use poor quality mesh in your sieving stations. So this is what we supply, hopefully. So safeguarding your operators, as I said before, it is about the powder, making sure that the powder is contained, but you also want to think about other things like PPE. These guys are wearing enough PPE. You don't really want to have to worry about things like ear defenders if the noise is too high. So we keep our noise levels down at 70 dBA. Machine needs to be small, so the operator can dismantle the machine nice and quickly, not having big pieces of equipment. Making sure it's got the correct compliance, so ATEX or ETL, so making sure that the equipment is suited to the market it's going into. So some other points to consider on your process. So you've looked at the operator safety, you've selected your equipment, and these are some of the things that you then need to look at when you're putting in the machine into your process. So I'm running out of time, so I'll just go through this, but making sure the sieving station is optimized, so less is more. If you get a sieving system which is efficient, then you don't need a big sieving station. You can have a much smaller sieving station. If you look at things like making sure you've got data logging, so Link 3D, we're talking about the process chain and validation, incorporating our system into that chain where you can start logging data about how much oversize you're getting, whether you're getting blips in your O2 levels. Being able to store that data and be able to present that in a validation would be very valuable, certainly for aerospace. So there's lots of things that you start to need to look at once your system is in your process. So again, these are things that you need to consider now as you upscale and move into the future. One other thing I wanted to touch on is the environment of the powder. So one of the studies that we're working on is how inert does your process need to be? So we have a system which can be not inert, so the powder is exposed to the air. You can have a partially inert system, so you can convey the powder in air and then purge it at its destination, or you can have a fully purged inert environment. So all of these systems, you need to consider it, because the more inert the system you want, the more complex it becomes. So it's very important that we understand what is absolutely necessary, rather than going too far to cover, to be careful. So we're trying to do some studies at the moment with some of our beta partners to really understand the impact of the oxygen in the environment to certain powders, to see whether you do have to go fully inert, to see whether we can go partially inert to help us simplify the process for you. So just to summarize, there's a lot to the powder handling process. It's not just about, I get my powder out of my machine, put it through there, and it's going to come back. We all know there are challenges when it comes to when the powder is coming out of the printer. We all see on LinkedIn and the various feeds the nice part of 3D printing, but the not so nice part, or the challenging part of 3D printing, is once you've done the part, made the part, how do you then get the part out of off the build plate? What do you do with the powder? How do you get that powder back into the process smoothly and efficiently? So talk to your suppliers. Again, feel free to come and see us to talk to you, so we can talk to you about how we can help you with your powder handling processes. So thank you for listening.